There's an epidemic spreading. Scientists say it can change your brain. It can release dangerous chemicals like formaldehyde into your bloodstream. It can expose your lungs to acrolein, which can cause irreversible damage. It's not a parasite, not a virus, not an infection. It's vaping.
Today we will be analyzing the contents of vape pods using gas chromatography. The vaping population has increased from 7 million adults in 2011 to 41 million adults in 2018, and this statistic is only expected to increase as the years go on. With so many people vaping, we were curious to see what exactly were people smoking. And so our objective was to identify and analyze the components and ingredients of 3 different flavors of vape pods. The flavors that we used were minty fresh, clear mango, and strawberry pink. In order to complete our objective, we did some literary research, and this was the article that we found: The Analysis of Nicotine and Impurities in Electronic Cigarette Solutions in Vapor. This was by James S. Harrington, Colton Myers, and Amanda Rigdon. The article looked at e-cigarettes while we looked at vape pods, and we also lacked pure nicotine to create a standard curve, and therefore we could not quantify the products. But besides these 2 main differences, the article was pretty spot on with what we wanted to do. The article suggested that we use a GCMS, and so that is what we used. And so we dissolved 1 milliliter of sample in 1 milliliter of methanol. We blanked our GCMS using methanol, and then we ran the GCMS. And here's Carlsy to explain how exactly a GCMS works.
Alright, for our assay, we used Agilent Technologies 7890GC system with an attached 5975C MS triple axle detector. As you can see here, this is our GC system, and then this is our attached mass spectrometer. If you open up the GC system, you'll find that there is a column, very long one, matter of fact, it's 30 meters long, that is hollow on the inside, coated with the stationary phase, a waxy substance. As you can see, the inside is 2.250 millimeters, and it is found in an oven. And here is the attached MS system, where the electron ionization occurs, where anything that elutes is bombarded with electrons. Alright, so explaining what happens in a GCMS. Well, it has 5 main components. Here you will find the helium gas, or the carrier gas, which is now being replaced by N2, but for our project we use helium. That is the mobile phase that is then supplied to the injection port. The sample injector will collect the sample in very small increments and inject it into the injection port, where it is vaporized, only to condense in the column. Once it condenses in the column, it will then react with the stationary phase, and as the ramp rate of the oven goes up and increases the temperature, they will elute and separate by boiling point in how much they react with the stationary phase. Once it elutes out of the 30-meter long column, it will go through our detector, which will perform electron ionization on whatever elutes, which bombards it with electrons. This bombarding of electrons is repeatable and can be redone multiple times over and over. That helps us because then we can set up a library of how each molecule will break apart. Once each fragment goes through that, the mass analyzer will then take their mass, and then it is sent to the computer to analyze. and go through our library. I'll now pass it on to Ryan to explain our results.
Before we talk about our experimental results, we have to talk about all the things we had to do before we could run our samples. One issue was that we had a really dirty column. This came from the previous user leaving a bunch of junk and garbage on the column for us to deal with. In order to clean the column, we have to do what's called a bake-off, which is where you and your friends spend a weekend in the kitchen and see who can make a better cake. Just kidding, a bake-off is when you heat your GC up really hot in order to clean it out. We had to bake the column because the last person to use it was experimenting with eggs and left all these eggy fatty acid and cholesterol compounds in the column. Some compounds either have no boil point or have boil points too high for the GC to heat up to. Sometimes these compounds will decompose before they boil, and those substances will fly off the column instead. Usually you keep running your bake method until it looks like the column runs clean, and then you can move on to your blank. Blanks are important because it allows you to identify your solvent peaks and lets you spot any contaminants before you run your sample. Usually your blank is just your solvent, which has a really low boil point like methanol. Methanol should have one peak, which you can see here at 3 minutes. However, the other two peaks at 8 and 21 minutes are likely contaminants from either the methanol bottle or the remnants of eggs. Contaminants in your solvent isn't normal, just FYI. So the first sample we ran was the orange mango flavor. Remember, our main objective was to spot the nicotine, and our secondary objective was to spot the flavor compounds in the vape juice. It's clear the vape juice is made up of more than just nicotine and flavor stuff because there's a lot of stuff going on with this chromatogram. Notice that pink strawberry chromatogram and the orange mango chromatogram appear to be very similar. Now look at Minty Fresh. Minty Fresh appears to have new peaks, whereas others have disappeared. So when you're looking at your mass spec, each of these peaks will have a corresponding spectra for the mass that goes through the mass spec. Each of these spectras are unique to the compound, and they explode apart predictably. So when you're looking these things up in a library, it's usually easy to spot them if they're pure and your peaks are coming out nicely. Here's another one of the orange mango. This one specifically is looking at 4.1 minutes. It's looking at the staircase of stuff here. This might have its own spectra depending on what it is, or it could be a blend of things, and that makes it a lot harder to really identify. Usually when you see these mass spectra, you use what's called a library search to look through. In this case, this is the NIST mass spec research library, and you can use this software to help spot all of your different chemicals. The one pictured is when we spotted nicotine. The computer will compare the spectra side by side. In this case, this was I believe this was nicotine overlaid with the library result. They're kind of similar, but there are small differences, and these small differences can really throw your search off if your compound is particularly dirty. In this case, we were able to spot most of the significant peaks. The main one is nicotine, which you can see here at 11.4 minutes. There's a lot of it in here. The package says it's like 4.5% nicotine. Since it's not a pure substance, it contains the other compounds such as nicotyrene, and you have your flavor compounds like ethyl maltol, which is responsible for your sweet or fruity flavor. The next significant one is menthol. Menthol gives you that cool taste that you sometimes get from menthol cigarettes, and in this case, vape juice. The two other primary components of vape juice are glycerin and propylene glycol, and with these being, more food grade products, they're not very pure, and you're starting to get pretty much all of the different polymerized compounds with the very small and light stuff coming off early on, and the heavier dimers, trimers, what have you, at much higher intervals. The same thing goes with glycerin. As it probably heats up, it polymerizes under the heat and explodes into this large grouping of polymers that express themselves in this sort of fashion. You'll run into this a lot when you run biological compounds or technical grade food products, which are not entirely pure. This is why you get a lot of these mess of peaks. This brings us into this unknown. It's obviously a major component of the spectra, and the problem here is that the computer, despite being so pronounced in its library searches, was unable to determine this peak at all with any significant clarity. The closest matches we got were like between 15 and 20% confidence. So this leads us to believe that this peak either shares a boil point with another compound and they're mixing horribly together, which is confusing the computer, or it's something that's not in the computer at all, which is very unlikely. The only other way we'd be able to separate these two compounds is if we really slow down our heat ramp rate. And if we slow that down, hopefully the compounds have slightly different boil points and maybe they'll separate. And we'll be able to get a better clue as to what they are. But because we haven't really done that, they've alluded together and it's a mess of just unknowns. Here's the other data from this pink strawberry flavor. The maltol gives you that fruity flavor, and ethyl butyrate is an orange flavor. That probably complements the citrusy tones of strawberry. And these are our citations.